So let's look at some examples on making use of this idea. So where are we going now? Firstly, this is a large sample test because our sample sizes are each 35. Sample size of 35, large sample. We're considering here whether there are differences in the population means. So in this example, our population means, we're looking to see if there's a difference in spending per pupil between urban and rural high schools. So these are sample statistics. So clearly we do not have the population standard deviation here. This is sample statistics, and we are given that assumption that we need to be able to make that the populations may be assumed to be approximately normal. So how do we go about doing this test? Now, of course, recall that this is a large sample t-test. So our test statistic calculation is based on calculating the test statistic t, which will be the difference in the sample means minus the difference in the population means on the top line. On the denominator here, we'll be looking at the population mean. So this is S1 squared, not the population mean, sample means for each of the samples, S1 squared over N1 plus S2 squared over N2. Now notice that those formulas there relate to first sample and second sample. So before we start to do our calculation, we should define our mean values. So we're going to use mean 1 to be the mean spending for urban schools, and we'll have mean 2 to be the mean spending for rural schools. So now we can use those notations without having to write urban and rural each time. So to do this calculation based on the numbers in the previous slide, the first sample mean, the sample mean for urban was 6,010. The sample mean for rural schools, 5,830. So that's our difference in sample means. Now notice that our hypothesized mean difference is going to be 0. We're looking to see if there's a difference. So we have a hypothesized mean difference of 0. And also from here, we now have our standard deviation values. So the standard deviation, 600 squared divided by sample size 1, and 500 squared divided by sample size 2. Both samples are 35, so we can do this calculation. Working out the numerator value, we have 180 on the top line, and that denominator value, make sure you're able to do this. This is the most complicated calculation that you would need to do on this course by hand, or using Excel, I should say, or your calculator. So we have there the square root of 17429, and that overall calculation comes out as 1.363. Now, of course, we've done the calculation for the test statistic here based on the difference of the means being 0, and that test statistic we'll be using in our hypothesis test. So, again, moving on to complete this test using this test statistic, we're going to use this test statistic here, which I'll write in again from the previous slide. And again, remember, we're using here mean 1 equals mean for the urban schools, and mean 2 to be mean for the rural schools. Mean spending, that is, for rural schools. So it's particularly important that you make it clear which one is which. So our null hypothesis here, we're considering, are the means the same? Or recall the original problem, are there differences? So if there are differences in the population means, then our alternate hypothesis would be difference in the means is not 0. So we're using independent, large sample, two-tailed test. This is a two-tailed test. not equal to 0. So now we have our alpha value, which was given in the problem as 0.10. Both samples were 35. So recall, to get our critical value, we need the degrees of freedom, which is smaller sample size minus 1, 35 minus 1, which is 34. And if we look at the t distribution for this, the t distribution with 34 degrees of freedom, here you can either use the tables or Excel. Again, as we've done before, we have a rejection region of 0.05 on each end, and this is a symmetrical distribution, so that critical test value there is 1.691. So we're using here either TINV from Excel, where we would use 0.10 for the alpha value and 34 degrees of freedom. This gives 1.691. Remember, in Excel equals TINV. This will be our critical t value in this problem, or we can use the tables for exam purposes, using exactly the same 34 degrees of freedom row and go along to find the correct t statistic. So from the t statistic here and our critical value, our decision, where would we find this test statistic in our distribution? We would be putting that test statistic, it would be about here, in between 0 and the critical value. So our test statistic is going to be about here. So it's in the do not reject region. Do not reject, because our test statistic is less than the critical value. And our conclusion then means if we have a do not reject, we have insufficient evidence at this value of alpha to suggest a difference in those population means, that there is a difference between mean spending per pupil between rural and urban high schools. And recall that the important note to do there is to write that conclusion in the context of the problem. Our next example